So we are going to be solving question on electrical instruments. We've already explained how some of those instruments works. Example is galvanometer, ammeter, voltmeter, and the likes. So in this question, in order to convert galvanometer to an ammeter, what must happen before the option? To convert galvanometer to ammeter, based on the acronym I gave you, we need a shunt in parallel. And shunt is a resistor of low resistance. So we check the options. The answer will be B. A low resistance shunt is connected in not series, it's also in parallel. Shunt in parallel, that will be, that's a low resistance shunt is connected in parallel, that's option A. So the answer here is A. Next question. A milliammeter of resistance 5 ohms. That should be the internal resistance R of the milliammeter, 5 ohms. And full scale deflection of 50 milliamperes. So it means Ig, this is Rg. Ig is 50 milliamperes. It's to be used to measure a PD of 50 volts. So in this case, we want to convert it to voltmeter to be able to measure 50 volts. So what's now the question? The resistance of the multiplier should be, we are looking for the multiplier resistance, and if you recall the formula, it is V over Ig minus Rg. So with the formula, it should be very easy. So V is 50, Ig is 50 milliamperes. So milli actually means 10 raised to the power minus 3, and this will give us 0.05 amperes. 0.05 minus Rg is 5. So if you divide 50 by 0.05, we are going to get 1000, and if you remove 5 from it, we are going to get the final answer, which is 995 ohms, and that's option D. Okay, next question. A milliammeter or galvanometer with full scale deflection current of 100 milliamperes, that is Ig. And milli is 10 to the power of minus 3. So if you place this milli with 1 over 1000, you get 0.1 amperes. As an internal resistance of 5 ohms, that is Rg, it will be converted to an ammeter with a full scale deflection of 1 amperes. So we want to allow it to measure up to 1 ampere. So this can be done by connecting a resistance of watts. And so this time around, we want to convert the galvanometer to ammeter. So we need shunt in parallel. So let's look for the shunt resistance. If you recall, the shunt resistance formula is, yes, that's the formula. So now let's impute the values. So let's impute the values. So Ig is 0.1, then I is 1 minus 0.1, then Rg is 5. So this will give me 0.5 divided by 0.9, and that's 5 over 9 ohms. So we need a shunt with resistance 5 over 9 ohms in parallel. So option A, 5 over 99, no. In series, not in series, 5 over 99 ohms in parallel with it. So that will be the answer. So but here we are getting 99. There is a mistake somewhere. So I think the problem should be from the question. Except if this I is 10 amperes. Here we are told that it will be converted to an ammeter with a full scale deflection of 1 amperes. If it should be 10 here, if what you have in here is 10, if you do 10 minus 0.1, you get 9.9. At the end of the day, you get 5 over 99. But according to the option, the closest is option B, 5 over 99 ohms in parallel, because we need shunt in parallel. So the answer is option B. For the next question, same pattern. A galvanometer of resistance 5.0, that's the internal resistance Rg, has a full scale deflection current of 100 milliamperes, that is I. But we know that milli means 1 over 1000 or 10 to the power of minus 3. So if you must replace this M with 1 over 1000, you are going to get our Ig to be 0.1 amperes. For a current of, how would its range be extended to 1 amperes? So we want it to be able to measure 1 ampere by placing a resistance of, in fact, this question is exactly the previous one, and I think this is the correct version, because the answer actually is option A, 5 over 9, same parameter, 5 over 9 in parallel, the answer is A. Next, Which of the following will convert milliammeter to voltmeter? To convert milliammeter galvanometer to voltmeter, we need a multiplier in series. So this multiplier has high resistance. So option A, low series resistance, no. Low parallel resistance, no. High series resistance, yes. This high series resistance. The answer is C. Okay, next question. A galvanometer of resistance 20, that's 20 ohms, is to be provided with a shunt such that 1/10 of the whole current in the circuit passes through the galvanometer. The resistance of the shunt is, in short, we are looking for the short resistance. So Rg is already given to be 20 ohms. Now, but they gave us Ig and I stylishly. So we are told that 1/10 of the whole current is Ig. So it means Ig is 1/10 of the whole current. So from here it means if you can multiply, I equals to 10 Ig. So if Ig, let's suppose Ig is 1 amperes, our I is going to be what? 10 amperes. If you do 10 times 1, you get 10. So now if you now input all the values here, our R shunt resistance becomes Ig is 1/10 minus 1, and our G is 20. So the answer is going to be 20/9. And the answer is going to be B, 2.22 ohms, option B. For the next question, a calibrated potentiometer is used to measure the EMF of a cell because A, internal resistance of a cell is small compared to that of potentiometer? No. Potentiometer has a linear scale? No. Potentiometer takes no current from the cell? Yes. The answer is what? C. Potentiometer takes no current from the cell, and that is why it's more accurate than voltmeter. So the resistance of potentiometer is less than that of a voltmeter. That not, yes, but not necessarily. So the answer is C. Potentiometers take no current, and I explained that during the course of the lecture. Next question. When a known standard resistor of 2 ohms is connected to 0.0 centimeter end of a meter bridge, the balance point is found to be 55. What is the value of the unknown resistor? For meter bridge, you call the formula I gave you. So R1 is the known resistor, which is 2. So the length is 55. So R2, 100 minus 55 is 45. From here, R2 becomes 2 times 45 divided by 55. Then you get R2 to be 1.64 ohms. That is option B. Okay, for the next question. A 0 to 10 milliamperes galvanometer, it means the full scale is 10 milliamperes, with a coil resistance of 30 ohms, that's Rg. So Ig is 10 milliamperes, Rg is 30 ohms. Okay, we need to convert this one to amperes always. So when you divide 10 by 1000, you should get 0.01 amperes as our Ig. Now, it can be converted to a 0 to 0. No, there's a mistake here. It's not meant to be 0 to 0 ammeter, but we don't convert it to ammeter. Let's say 10 amperes ammeter by using a dash. So let's suppose we want to turn it to a 10 amperes ammeter by using what? So to convert the galvanometer to ammeter, we need a shunt in parallel. So we have to get the shunt resistance, Rs. And I think you can do that yourself. Same formula. Shunt resistance equals to Ig over I minus Ig times Rg. Do that yourself and go with the option. Pick the option. For the next question, a moving galvanometer of 300 ohms resistance, that's Rg, gives a full-scale deflection current or deflection for 1 milliamperes, that is Ig. The resistance R of the shunt, we are looking for shunt resistance, similar to what we've done. So this 3 amperes is I. So you can do this yourself also. The diagram shows a meter bridge in which 2 of the arms contains resistance R and 2 ohms. So this is 2 ohms. The balance point is obtained to be 60 from the left end. Calculate the value of R. That's meter bridge. So for meter bridge, remember the formula R. So R1 is R, L1 is 60, R2 is 2, L2 is 100 minus 60, which is 40, already given in the question. From here, our R becomes 60 times 2 over 40, and that will be 3 ohms. Option C. Now for the first part, a galvanometer of internal resistance 50 ohms has full scale deflection for current of 5 milliamperes. So this is RG, IG. What is the resistance required to convert it to a voltmeter? That's GVMS. In this case, we are going to use multiplier resistance. And RM equals to V over IG minus RG. So the V in the question is 10 volts. IG is 5 milliamperes. And milli is 10 raised per minus 3. So that will be 0.005 minus RG is 50 ohms. So if you divide 10 by 0.05, you get 2000 ohms minus 50 ohms, and that will be 1950 ohms, which is option B. Now for 67, in a meter bridge experiment, two resistors 2 and 3 ohms occupy the left and the right gap respectively. So this 2 is to the left, this 3 to the right. Find the balance point from the left side of the bridge. So formula, R1 over L1 equals to R2 over 100 minus L1. So what is R1? The one to the left, 2 over L1 equals to R2 is 3 over what? 100 minus L1. If you multiply from here, you have 200 minus 2L1 is 3L1. So 200 equals to, you bring this minus 2L1 here, becomes plus 2L1. 3 plus 2 is 5L1. By the time we divide by 5, 200 over 5, we get our L1 to be 40 centimeters, which is option B. But be careful, if you put 3 here and 2 here, you are going to get 60, which will be wrong. Now, next question. A moving coil galvanometer has a full scale deflection of 3 amperes, equivalent to 30-degree deflection. The sensitivity of the instrument is, I didn't talk about this during the course of lecture, but whenever you are told to look for the sensitivity, how sensitive a particular sensitivity, so it can be in terms of the change in PD per degree, or it can be change in current per degree. So yeah, it means for 30 degrees, it's going to deflect 3 amperes. So that will be 3 over 30 degrees. And this will give 0.1 amperes per degree. So the answer is D. The diagram above shows a balanced meter bridge. The value of X is, so what happened here, we have this 8 and 8 in parallel. If we combine this 8 and 8 in parallel, we should get 4. 8 times 8 is 64. 8 plus 8 is 16. 64 plus 16 is what? 4. So it means to the left hand side here, the resistance is what? Is 4. Using the formula R1 over, in this case our L1 is X. R2 over 100 minus X as usual. So our R1 is, these two combined in parallel will give us 4 over X. And R2 is 8 over 100 minus X. 4 here 1, 4 here 2. If you can multiply, you get 2X equals to 100 minus X. Minus X plus 2X, that's 3X equals to 100. Then X equals to 100 over 3. So she gets 6.7. The answer is option A. Sorry, not 6.7, it's actually 33.3. And the option is C. With all the questions we've solved, so all the questions on galvanometer seems to be extremely easy now. Like this question, although the pattern there is a bit different, but same formula. A galvanometer with full scale deflection current of 10 milliamperes. So it means IG is 10 milliamperes. Milli is 10 raised to minus 3, so this becomes 0.01 amperes. Continue. It's to be converted to a voltmeter, that's GVMS. So we need to get what? Multiplier. So I will know that for multiplier, RM equals to V over IG minus RG. Now let's continue. With full scale deflection of 5 volts. So you want the V actually. This time we're not looking for V. Sorry. as usual. V is given to be 5 volts. If a series resistance of 498 ohms is used, in this case we are already given a multiplier resistance to 498 ohms. So coming to this formula, we can look for what? The resistance of the galvanometer, Rg. So let's bring this minus Rg here. So it means Rg equals to V over Ig minus Rm. Just swap. So from here it means our Rg equals to V is 5, Ig is 0.01, Rm is 498. So our Rg becomes 500 minus 498. So our Rg becomes 2 ohms. And I think with this, we are done. See you in my next class, where we are going to talk about alternating current circuit, simple AC circuit.